And then our geometric sequence is a sub n is equal to a sub 1 times r to the power of n minus 1. So these you're not given. These you have to know for the test. The ones that are given are going to be your arithmetic sum. So S sub n is equal to n over 2 times the first term plus the last term. So this is for an arithmetic sum. And then we have two geometric sum formulas. S sub n is equal to, when it's an infinite sum, it is a sub 1 over 1 minus r. And when it's a finite sum, it is a sub 1 times 1 minus r to the power of n over 1 minus r. So these are geometric. The first one is an infinite sum. The bottom one is finite. So we give you the three sum formulas, but we don't label them, so you have to know which one's which one's arithmetic, which one's geometric. And you have to know these two. So let's start with number 1. Pick the second one here. It says write the first 5 terms of the sequence. Assume n begins with 1. So when we're writing our first 5 terms, we just plug in 1 through 5 into our n. So a sub 1 would be 3 times 1 over 1 squared minus 2. So that would be 3 over 1 minus 2 would be negative 1, which would be negative 3. All right, so let's plug in a sub 2. So 3 times 2 over 2 squared minus 2 would be 6 over 2 squared is 4. 4 minus 2 is 2. And 6 over 2 simplifies to what? 3. Good job, guys. Then we have 3 times 3 over 3 squared minus 2. So 9 over 7. Can't simplify that one. A sub 4 would be 3 times 4 over 4 squared minus 2. So 12 over 4 squared would be 16 minus 2 is 14, which simplifies to 6 over 7. And then lastly, a sub 5. We have 3 times 5 over 5 squared minus 2. So 15 over 25 minus 2 would be 23. And that doesn't simplify. So these would be our 5 terms. If you have a question like this, just make sure you simplify whatever fraction you have as much as you can simplify. Don't leave a fraction unsimplified. All right, next let's look at number 2, the first one here. So it gave us a sequence or a formula. We have to find the 16th term. So we just plug in 16 into our n. So we have 16 squared over 4 times 16 minus 3. Let's plug this into our calculator. 16 squared would be 256 over 4 times 16 is 64, minus 3 would be 61. Always double check to see if you can simplify. I don't think that this simplifies anymore. All right, let's take a look at number 3. So it says write an expression for the apparent nth term of the sequence. So here we got to figure out, is it an arithmetic or a geometric sequence? Are we adding the same number to get from one term to the next, or adding or multiplying? We're adding what? Negative 5. Awesome. So that would be our common difference is negative 5. So this would be a this is an arithmetic sequence. Yeah. So a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, what's our first term? -3 times n minus, no, plus. My brain stopped working. Plus n minus 1 times -5. Let's simplify. We want to distribute. So a sub n is equal to -3 plus minus 5n plus 5. So a sub n is equal to -5n plus 2. So that would be our rule. Is that what this question's asking us for? Yeah. So just to write an expression, which is just our rule, our general rule to find the nth term, a sub n. It's all the same thing. Does that make sense? Yeah, yeah. Let's do the one on the bottom because we love fractions. It's helpful to give everything a common denominator. That way you can see better what you're adding to get from one number to the next or multiplying by. So I'm going to make 1 be 2 over 2. And I'll make 4 be 8 over 2. I'm not changing the value of it. I'm just changing the way that it looks to give everything a common denominator. What are we adding to get from one number to the next? Over 3 over 2. Perfect. So we're adding 3 over 2 to get from one number to the next. So that is our common difference. So we'll plug that into our general formula. A sub n is equal to our first term, -1/2, plus n minus 1 times d, which is 3 over 2. Let's simplify a little bit. We'll distribute here. So -1/2 plus 3 over 2 times n minus 3 over 2. So we get 3 over 2 times n. -1 over 2 minus 3 over 2 would be -4 over 2. What does -4 over 2 simplify to? -2. So that would be our general rule, or our nth term, a sub n. So on the test, when it asks you for different ways that it can word it, but either your general rule or your general formula or the nth term or a sub n, it's asking you for the formula. You leave n as a variable. You don't plug in anything. It's going to want the formula. Then it might also ask you for like the 50th term. So then you would plug in 50 into your n. If it asks you for the formula, you just leave n as a variable. All right, so number 2, the second one here, it asks us to find our 19th term. So we just plug in 19. So a sub 19 is equal to -1 to the power of 19 minus 1 times 19 times 19 plus 1. So we're just going to do one step at a time. -1 to the 18th power would be what? Is it positive or negative? It'd be 1. It's positive 1. And then we have times 19 times 20. So we can just multiply all of these together. So 19 times 20 times 1 would be 380. So number 4, but the second one. Also on the first one for number 4, this has 2 exclamation points. That's just a typo. It should only just be 1. 2 exclamation points doesn't mean anything. Let's do the second one here. So we have 12 factorial times 5 factorial over 4 factorial times 7 factorial. So I'm going to write this out so I can simplify so I don't have to just put it all into my calculator. So I have 12 times 11 times 10 times 9 times 8 times 7. I'm going to stop here because I know that I have a 7 factorial that this will cancel out with on the bottom. So I'm going to stop there. Let's write out the 5 factorial. So we have 5 times 4. I see that I have a 4 factorial on the bottom, so I'm going to stop here because I know that will also cancel out with the 4 factorial on the bottom. If you want to write it out all the way, you can, but I see that the 4 factorial is going to cancel and also the 7 factorial will cancel. So any common factors in the top and the bottom we can cancel. So 7 factorials cancel and 4 factorials cancel. Then up top, we just have 12 times 11 times 10 times 9 times 8 times 5. So we'll put this into our calculator. 12 times 11 times 10 times 9 times 8 times 5. So that gives us 475,200. I know when you did the first one here on number 4, it gave you a scientific notation. If that's the case on the test, just leave it in scientific notation. Some calculators were different, so some gave you the whole value. Some gave you like 1.7 with all the decimals and then said 10 to the power of 10 or times 10 to the power of 10. That's okay. Just if it gives you scientific notation on the test, leave it in scientific notation. Just put however the calculator tells you. Next, let's do number 6. So this is the fun one, where it doesn't give us our first term and it doesn't give us our common ratio. We're going to use our formula. So a sub n is equal to a sub 1 plus n minus 1 times d. And we knew that it was going to be an arithmetic sequence because it told us that in the question. So we knew that we had to use our arithmetic sequence formula. Not every question will say it, but for a question like this where like it doesn't give you the first term, it doesn't give you if you have a common ratio or common difference, it'll say it. So questions like these will be specific. Not every question is going to say it. You may be able to figure it out if it gave you like the first 5 terms of the sequence. You can figure if it's arithmetic or geometric. All right, so let's start with what we're given. What would we want to start with here though? A sub 12 or A sub 18? 18. Why do we start with A sub 18? It's farther from 1. So you always want to start with the term that's farther from 1. Start with the farther term. Farther meaning farther from the first term. So A sub 18 is equal to A sub 12 plus, what goes into our parentheses? 18 minus 12 times d. All right, so let's plug in what we have. We know A sub 18 is 31 is equal to A sub 12, which is 13, plus 18 minus 12 would be 6d. We're solving for d here, so we're going to subtract 13 on both sides. So 18 is equal to 6d. Divide both sides by 6. So we get 3 is equal to d. Now this question, going back to what the question's asking us for, it wants us to find the 47th term, but it also wants us to find the general formula. So let's find our general formula first, then we could just plug 47 in to that. But if we're going to find our general formula, we need to know what A sub 1 is. We need our first term. So next, I'm going to do the same thing I just did, but I want to find A sub 1. You can either use here A sub 12 or A sub 18. It doesn't matter. You'd get the same answer. I'm going to use A sub 12 just because the number is smaller. So starting with A sub 12, that's going to be equal to A sub 1 because that's what we're looking for. Plus, what's going to go into our parentheses here? 12 minus 1, perfect, times d, which is 3. So when we plug in what we have, A sub 12 is 13, is equal to A sub 1 plus 11 times 3. So 13 is equal to A sub 1 plus 33. Subtract 33 to move it to the other side. What's 13 minus 33? Negative 20, awesome. So negative 20 is our first term. So now when we write our rule or general formula, we're going to use our common difference and we're going to use our first term. So a sub n is equal to negative 20 plus n minus 1 times d, so times 3. Let's simplify this a little bit. So we'll distribute the 3. So a sub n is equal to negative 20 plus 3n minus 3. And then combine like terms. So a sub n is equal to 3n minus 23. So this is our a sub n. When the question asks you to find a sub n, it's asking for your general formula. You just leave n as a variable. Nothing gets plugged into your n when it asks for a sub n. So this is part of the question when it asks us for a sub n. The other part of the question says to find a sub 47. How can we find our 47th term? Plug in 47 into n. We're going to plug it into our general formula here. So a sub 47 is equal to 3 times 47 minus 23. Now we can just put this into our calculator. 3 times 47 minus 23 would be 118. So number 10 says write a formula for the general term, the nth term of the arithmetic sequence. Then use the formula for a sub n to find a sub 20, the 20th term of the sequence. So this is an arithmetic sequence. So we know a sub n is equal to a sub 1 plus n minus 1 times d. This is our formula that we're going to use. We need to know what our a sub 1 is and our common difference so we can plug it in to find our general term, our nth term, which is just the formula. So what are we adding to get from one term to the next? Negative 9. Perfect. We're subtracting 9, so that just means d is going to be negative 9. So we have a sub n is equal to, what is our first term? 10 plus n minus 1 times negative 9. When it's asking us for the formula, the nth term, we just leave n as the variable. So I'm going to distribute here just to simplify. So a sub n is equal to 10 plus 9n plus 9. So 9n plus 19 would be our formula. Negative 9n, you are right. Negative 9n plus 19. Just making sure you guys are paying attention. All right, so this is the first part of the question. Second part wants us to find a sub 20, so the 20th term. How do we find a sub 20? Plug in 20 in for n, so we're going to plug it into our general formula here. So negative 9 times 20 plus 19. So plug it into your calculator. Negative 9 times 20 plus 19 gives us our 20th term as negative 161. So 13 says use the formula for the sum for the first n terms of an arithmetic sequence to find the indicated sum. So for this one, it tells us it's an arithmetic sequence. We can't sit here because we don't have all day to plug in 1 through 20. So we have to use, or 1 through 30, we have to use our formula. So we're going to use our sum formula for an arithmetic sequence. So that is n over 2 times a sub 1 plus a sub n, where n is our number of terms, a sub 1 is our first term, and a sub n is our last term. Does anybody remember how we find n? Awesome. Top minus bottom plus 1. Now, if your bottom number is just 1, your n is just the top number. but it's not always going to be the case where your bottom number is 1. So we do top, which is 30, minus the bottom, plus 1, which would be 30. How do we find our first term? What do we do? Awesome. We're going to take the number on the bottom, our starting number, plug it into the variable. So we have 3 times 1 minus 6. 3 times 1 would be 3, minus 6 would be negative 3. So a sub 1 is negative 3. How do we find our last term? Awesome. Take the ending number, plug it in. So 3 times 30 minus 6. 3 times 30 is 90. 90 minus 6, 84. So let's plug all of that into our formula. So we have 30 over 2 times negative 3 plus 84. So that would be 15 times 81. Just put it into your calculator. 15 times 81 would be 1,215. So that would be our sum. Yes. It doesn't matter. If you wanted to make this a sub 30 or s sub 30, it doesn't matter. Sometimes for these questions, it won't tell you if it's an arithmetic sequence or a geometric sequence, but you can tell by looking at your equation. So if it gives you the sum, and if the equation's written kind of in the form of y equals mx plus b, where it has just like your n or your I, whatever your variable is, times a number plus a number. So if it was written in the form of like mx plus b, where like that's your variable, you've got a number times it, this would be arithmetic. If your sum was written where you have an exponent, so let's say, r to the power of whatever, it could be n minus 1 or I minus 1, or it looks like the geometric formula where it has an exponent, this would be geometric.
And that's for like the other ones too, like if there's anything with an exponent, it's just going to be geometric.
Yeah, so keep in mind your formulas. I'll go back to the formulas on the last page. But if your n or your I, if your variable is just being multiplied to the number, it's arithmetic. If it's your variable is an exponent, it's geometric. So 11 says find the sum of the first 30 terms of the arithmetic sequence. So sum of an arithmetic sequence formula is s sub n is equal to n over 2 times the first plus the last. So what's our n here? What does the question say? 30 terms. It tells us that we have 30 terms. What's our first term? 6. How do we find the last term? We got to come up with a rule to find the last term. We have to find our general formula to find our 30th term. So a sub n is equal to, our first term we know is 6, plus n minus 1 times d. What's our common difference? What are we adding to get from one number to the next? 10. We're looking for our 30th term, so I'm just going to plug 30 into n. So we have 6 plus 30 minus 1 would be 29 times 10. So 6 plus 290. So our 30th term would be 296. Now that we have our n, our first term, and our last term, we can plug it into our sum formula. So s sub n is equal to 30 over 2 times 6 plus 296. So we get 15 times 302. Put it into your calculator, and that'll give you 4,530. So that would be our sum. So 17 says write a formula for the general term, the nth term of the geometric sequence. So sometimes for a question like this, it may not tell you that it's a geometric sequence, but we can figure that out just by looking at our sequence here. Am I adding the same thing to get from one number to the next, or are we multiplying the same thing? We're multiplying, so we know it's a geometric. So since this is a geometric formula, then we use our a sub n is equal to a sub 1 times r to the power of n minus 1. What are we multiplying to get from one number to the next? 2. So that would be our common ratio, multiplying 2. Remember, if we can't see that right away, you could always do the second term divided by the first to find your r. So 12 divided by 6 would be 2. And then we also need to know our first term. What is our first term? 6. So let's plug that into our formula. A sub n is equal to 6 times 2 to the power of n minus 1. The nice thing about the geometric formula is you just need to plug in your a sub 1 and your r. You don't simplify anything. You definitely cannot multiply the 6 times the 2. Absolutely not, because that 2 has an exponent. So you just leave it as 6 times 2 to the power of n minus 1. Does this ask us to find a specific term? Nope, just the formula. So that would be our answer. 20 says find the indicated sum. Use the formula for the sum of the first n terms of the geometric sequence. So let's just find the sum here. So this, we knew it was going to be geometric because the I is an exponent. So we're going to use our geometric sum formula. Is this a finite geometric sum or infinite? It's finite. It doesn't go to infinity. So our finite geometric sum is S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So we want to find our first term, our common ratio, and the number of terms. How do we find our first term? We're going to take 4, the first number, the starting number, and plug it in. So we have 4 to the 4th power. We'll put it into our calculator. 4 to the 4th power times 2. So our first term is 512. What's r? How do we know that it's 4? Because 4 has the exponent. R is the number with the exponent. So 4 would be our r. So whatever your base is that has the exponent, that's your r. And then how do we find n? Top minus bottom plus 1. So 15 minus 4 plus 1. So 15 minus 4 would be 11 plus 1 is 12. So n would be 12. So to find n, you do top minus bottom plus 1. All right, let's plug everything into our formula. So S sub n is equal to 512 times 1 minus 4 to the power of 12 over 1 minus 4. All right, so be careful how you put this into the calculator. You can do it all at once if you like, but just make sure you put the top in parentheses and the bottom in parentheses. So if you do it all at once, you definitely want to put the top in parentheses and the bottom parentheses. I like to do the bottom first just to break it up so I don't have to worry about my parentheses. But 1 minus 4 would be negative 3. That way I can just divide that after I put the top part in my calculator. So I have 1 minus 4 to the 12th power, which gives us a big number, negative 16,777,215. Then we're going to divide that by negative 3. Still have a big number, but that's fine. Then we're just going to multiply that by 512. So we get an even larger number. 286331136. That would be our number. That's our sum. If it didn't say infinite, how could we tell that this was an infinite geometric series? The dot, dot, dot means that it goes on forever. And it doesn't say, because we had one like this in the homework where it did have a dot, 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 but it said like, or in the notes, it said find the 150th partial sum. It doesn't give us a value for n here. It doesn't say find the sum of the first 10 numbers of the sequence. It doesn't give us an n. It only gives us the dot, 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 so we know that it's infinite. So our infinite sum formula is S sub n is equal to a sub 1 over 1 minus r. So we need to know our first term, and we need to know our common ratio. What's our first term? 48, perfect. What's our common ratio? What are we multiplying by to get from one number to the next? 1/4, awesome. If we didn't see that right away, you could always do the second divided by the first. So 12 over 48 would be 1/4. So let's plug that in. So our sum is equal to the first term, 48, over 1 minus 1/4. You can plug this all into the calculator at once, but just be careful. Not only would you need to put the parentheses in the bottom, any fraction that you have, you want to put that in parentheses too. So we have 48 divided by parentheses 1 minus parentheses 1 divided by 4. And close the parentheses. What do you get when you put this in the calculator? So you should get 64 here. So 22 says find a sub 1 and a sub n, given a sub 3 and a sub 8 of the geometric sequence. So here it tells us that it's a geometric sequence. So we know that we're going to use our geometric formula. A sub n is equal to a sub 1 times r to the power of n minus 1. But we don't have our a sub 1 and we don't know what n is, or we don't know what r is. So since we're missing two things, we can't just plug it right into the formula and solve. We have to use what we're given. So out of the two here, a sub 3 and a sub 8, what would we start with? A sub 8, because that's farther from the first term. So a sub 8 is equal to a sub 3 times r to the power of what? 8 minus 3. Perfect. Instead of using n minus 1, we use 8 and 3. So we would say 8 minus 3. So let's plug in what we have. A sub 8 is 1 over 625 is equal to a sub 3, which is 5, times r to the power of 5. So let's divide by 5. We're solving for r, so we want to get r all by itself. When we have a fraction and a fraction, what do? Keep, change, flip. Keep the top, change multiplication, flip the bottom to 1 over 5. So we get 1 over 625 times 5. Which should be 3,125. When you're doing questions like these, be careful. You do have your calculator, but don't just throw everything into the calculator, because the question on the test is going to say exact values. It does not want decimals. So leave it as a fraction, so you just have to be careful how you do the math. The calculator is just there to assist you, but not do it all for you. Now, how would I get r all by itself? We take the 5th root of both sides. So we get r equals, the 5th root of 1 would just be 1, but the 5th root of 3,125 would be 5. Noah. You could do 3,125 to the 1/5 power, but make sure you put it in parentheses if you do that. All right, so we found r. Let's the question asks us for a sub 1 and a sub n. So we got to find a sub 1 to find our general rule. So we'll come up with a sub 1 next. So we could use either one. You could use a sub 3 or a sub 8. I'm going to use a sub 3 because it's a whole number, not a fraction. But it'll work with either one. So we could say a sub 3 is equal to a sub 1 times r. What's r? 1/5. We just found that. To the power of what now? 3 minus 1. Perfect, because we changed the a sub n to 3. So instead of n minus 1, we say 3 minus 1. So a sub 3 is 5, is equal to a sub 1 times 1/5 to the power of 2. Again, be careful when you put this into the calculator. Your calculator is just there to assist you. We don't want fractions. We don't want decimals with your answer here. We want fractions. So leave it as a fraction. We're going to square this. So 1 squared would be 1 over 5 squared, which is 25. How would we get a sub 1 all by itself? Divide by 1 over 25. What are we doing? We have a fraction and a fraction. Keep, change, flip. We're going to keep the top, change multiplication, flip the bottom to 25 over 1. So we get 25 times 5, which would be 125, is equal to a sub 1. So that's our first term, and we have our common ratio. Now we can plug it in to find our nth term. So a sub n is equal to a sub 1, so 125 times 1/5 to the power of n minus 1. Remember, when it asks for your general formula, your general rule, or your nth term, you leave n as a variable. This would be our answer. So 18 says the general term of a sequence is given. Determine whether the given sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, find the common difference. If it's geometric, find the common ratio. So this is kind of like what I was talking about before when we had a summation one. If it's in the form of y equals mx plus b, like where you're just multiplying, it's going to be arithmetic. If it has an exponent, it's going to be geometric. So we can tell just by looking at this that it's going to be arithmetic for the first one. But if you wanted to plug in some terms to figure out that it's arithmetic and see that you're adding to get from one number to the next, you could totally do that. So if we plugged in a sub 1, let's do a sub 2 and a sub 3. We'll find the first three terms. So 3 times 1 minus 2 would be 1. 3 times 2 minus 2 would be 4. 3 times 3 minus 2 is 7. What are we adding to get from one number to the next? 3. So what's our common difference? Our common difference would be 3. Also, your common difference is whatever your slope is. So just by looking at it, you could see what your common difference is going to be. Same idea with the second one here. Because n is an exponent, we know that it's going to be geometric. When we have a geometric equation, when we're doing the sum questions, how do we know what our common ratio is just by looking at it? It's the base with the exponent. What's our base here? 4. So we know that our common ratio is going to be 4. But if you didn't know that, plug in the first few terms and see what are you multiplying to get from one number to the next. So a sub 1 would be 4 to the first power. So that's 4. A sub 2 is 4 to the second power. So we have 16. A sub 3 is 4 to the third power, which is 64. So we're multiplying 4 to get from one number to the next. So that's our common ratio.